Resonance structures give us a way to look at the electron cloud of molecules while still using a two-dimensional Lewis structure. Resonance is a method to describe the delocalization of electrons within molecules. Resonance structures are used when one Lewis structure does not fully describe the bonding between adjacent atoms in a molecule. If we look at an example like the nitrite ion, if we see here's the Lewis structure for the nitrate ion. If we only consider this Lewis structure, it looks like one of the oxygens has a full formal negative charge and the other oxygen does not. This only represents one snapshot and not the reality of what the nitrite ion is with its electron cloud and separation of density. We can think about resonance structures as following a few rules that we'll get in more detail later. One of them is we cannot change the overall structure, so the nitrogen needs to be bonded to both of the oxygens. What we can change in resonance is the delocalization of electrons. Electrons that we can move without impacting the overall structure. Here we can move our lone pair towards the nitrogen, but now we're going to have too many electrons on nitrogen, so we'll move the pair of electrons that are in this pi bond towards the other oxygen. The result of this will be a new Lewis structure. This new Lewis structure, you'll see that now the other oxygen has a double bond to nitrogen, and the first oxygen that was double bonded is now single bonded, and we've moved the negative charge. So we have the formal charge on the other oxygen. The true representation of the nitrite ion is a combination of these two resonance structures. We can think about it in this structure. We can see this hybrid structure. I've left out the lone pairs, but you can see that it can be considered that the nitrogen and oxygens are partially double bonded and that we don't have one oxygen double bonded and the other one single bonded. This is what we mean by delocalization of electrons and using more than one Lewis structure to represent the overall properties of the molecule. Let's look at the rules in more detail. The rules for resonance structures. Atoms never move. We have to keep our structure the same. Move electrons in pi bonds and lone pairs. Do not move sigma bonds, that is, the single bonds, because that'll change the structure. The overall charge of the system must remain the same. We're not adding or subtracting electrons. The connectivity of the molecule must remain intact. We can't detach different atoms or move them around in the structure. This goes back to the second rule where we cannot move electrons in sigma bonds. If you follow these rules, you'll be able to draw resonance structures easily. Let's look at an example. How many resonance structures can be drawn for the nitrate ion, NO3-? For this one, let's start with the Lewis structure. If you don't know how to draw the Lewis structure for the nitrate ion, please review that section. If we look at this structure, we see that we have our base structure where we have a nitrogen in the center and oxygens around it. This base structure is something that we're not going to be able to change. This is the connectivity. We have a nitrogen in the middle and three oxygens around it. We also know that we have an overall negative charge because in our correct Lewis structure we have a positive on the nitrogen and two of the oxygens have negatives. What we can consider moving is our electrons that are in pi bonds. That means anything that's more than a single bond, and our lone pair. When you move the electrons, remember that moving electrons in towards a bond is going to be making a bond, and if we move some out, that's going to become lone pairs. So then that will become this structure. We can see in this structure that now we've moved the formal charge on the oxygen at the top, and we've now formed a double bond nitrogen-oxygen bond to our oxygen on the right. Is there a way for us to make another Lewis structure? Well, if we look at it, we have not included the other oxygen. So let's start with that one, with the lone pairs on the oxygen to the left. Moving those electrons up, again, now we have too many electrons of nitrogen, so we're going to have to move electrons out. So we'll move electrons in the pi bond out. That's going to give us this structure. As you can see in this structure, now what we've done is actually delocalize the negative charge onto all three oxygens. So we can represent this overall structure. And again, in this hybrid structure, I'm going to ignore where my lone pairs are and the formal charges and just represent the charge of the overall atom. Resonance structures give us a way to present delocalized electrons within the Lewis structure framework. Lewis structure is just a way to represent electrons and bonds, but the actuality is that the electrons are flowing around the molecules in electron clouds. Resonance structures give us a good way to visualize this. Practice resonance structures and become confident.